Welcome everybody to week 6, day 1. We're going to talk about functions, comments, overloading, and the hack the mainframe homework assignment. So let's get to it. I've got a PowerPoint presentation to use here, and that has a little bit of stuff I'd like to go over. So, a lot of the stuff you know already, Fahrenheit to Celsius. One thing to note about this is that the variable far up in a function is a different variable than this here. Variables in different scopes can have the same name. They're different variables. They're not the same thing. This does not make it call by reference, right? If you modify far down here in main, this variable lives within these curly braces here. That's its scope. This one's scope exists between here and here. So a lot of times students think, well, just because it has the same name, no. If you did what we did last time, where you see out the address of a variable, you could verify that this spot, the address that cell is in RAM, is different than the cell down here. Different locations in RAM that are being read and written to. So they're different variables. They just happen to have the same name. Another thing to talk about is that functions can call other functions. So main can call a function that calls a function that calls a function. Functions can even call themselves. It's called recursion. And we're not going to worry about recursion right now. But one thing I do want to point out is that a lot of times you can save yourself from having to write a lot of code by reusing old code. So for example, here it's a very simple example. In real life, you probably wouldn't do it, but it illustrates the point. So here we've got add, and rather than rewriting this function here, we're actually going to implement subtraction by just using add, right? So we're going to flip b from positive to negative or negative to positive, and then call add. And like I said, on a one-liner like this, it's not worth doing it. But if you're doing a big function, a lot of times you can do something like this and save yourself quite a lot of retyping and copying and pasting, and every time you copy and paste, there's a chance you make a mistake. For example, if you were to compute shortest paths, shortest distance, if you were to compute the distance that Fresno is from every city in America to find the shortest path to somewhere, in the process of doing that computation, you've also computed the longest distance, right? You're going to write down, Los Angeles is this far away and Detroit's this far away and things like that. Just as a side product of computing the shortest path, you've also computed the longest path or the longest distance. So rather than copying and pasting that giant thing a second time, you could have a longest distance function just call into the earlier one and maybe pass in a Boolean or something like, hey, give me the longest value instead of the shortest value. And then you don't have to rewrite anything. You get two functions for the price of one, so to speak. Whenever you find yourself copying and pasting code, that should be a warning sign to you that maybe there's a better way. There's not, it's not always the case, but if you're copying and pasting and not modifying it, right? That's oftentimes a sign that it needs to turn into a function or something needs to change. Because computer science majors really don't like seeing the same blocks of code over and over again. One-liners, sure, fine. Whatever. You don't need to worry about it. Adding two variables, whatever. You don't need to make a function for that. Like, this is probably not a very good function. It's just doing one line of code. So, you've replaced one line of code with one line of code. There's absolutely no point to calling add AB, right? But the reason why I have it here is so I can demonstrate you can have one function call another function, and oftentimes we'll do that to save on duplicating our work. So, brings us to the next topic, which is commenting your code. So commenting is one of these really controversial things that shouldn't be controversial, and everybody agrees they shouldn't be controversial because their way of doing it is the right way of doing it. And everyone else is wrong, which is why it's controversial. When I took this class, when I took CSI 40, obviously it wasn't called CSI 40, at UC San Diego, they would knock you off a letter grade if you didn't comment your code the way that the TA wanted you to comment it. And that's one of the reasons why I don't grade you on that kind of stuff, because it's stupid, for one thing. I mean, sure, it's good. It's good to get people into the habit of writing comments, right? Like, I'll pull up some code in a bit, and you'll see one of my top students, Shami. I randomly chose his code earlier, actually. It's page after page of code with no comments on them whatsoever, and that's not good, right? So in general, here are my rules for commenting code. Okay. Every function should have a little line up top like this that tells you what the function does. Okay? This is what the function does. Just a little one-liner. You know? And if you're unclear what the parameters are, explain what those parameters are too. This is what this means. If I have a boolean called error, what the hell does that mean? Like, tell me. Just tell me in English what it means. What does this function do? What are the parameters? That's all I really care about. And a lot of times you'll see documentation that's like, get rrqval, and the document, like, that's the name of the function, get rrqval, and the documentation is this gets the rrqval. I'm like, no, that doesn't help me. I don't know what an rrqval is. You need to, like, don't assume that I know your abbreviations. I don't know what an rrq value is. And it's utterly useless when you see comments that way, comments that are just like describing, like, it's just repeating the code. You know, that's a waste of space. It's a waste of brain power. Like, and that's how my TA wanted me to write codes, which drove me crazy. He wanted us to comment every line of code. So if we had this line of code here, float C equals A plus B, he wanted me to write, this line of code adds A and B together and stores it in C. And it's like, I don't need to write that, because that's literally what it's doing. I don't need to write, this creates a floating point number named C and sets it equal to A plus B. No, I don't need to write that. That's self-documenting code. Self-documenting code is when it's pretty damn obvious from what's happening here what is going on. I don't need to write a line of code saying this returns the value of C. It's right there. I don't need to repeat it. So a lot of people write redundant and unnecessary comments on one side. On the other side, some people just don't write comments at all. And that's really bad too. Because one of the biggest problems, especially for new programmers, is that they write not great code, and then they come back to visit their code a year later. And by the way, one thing I recommend all of you guys do is back up your program at the end of the semester. Back up all of your programs. And make a record of every programming assignment you ever make in your life. And then after a year or so, revisit your old code and see what it looks like, you know? And you're like, and what the hell am I doing here, you know? And a lot of times you're not going to remember what you did a year ago. And you don't know what you were trying to accomplish. You don't know why you wrote the code that way. And that's where comments are useful. Anytime there's a question of, like, what's going on, like, what's my purpose for this chunk of code, put a comment there. My general rule of thumb is anytime there's like a WTF, like, wait, why are you doing this? Like, why are you calling add for subtract? You know, anytime somebody might quirk an eyebrow like this at you and be like, you know, question mark? That's a sign that you need a comment there. Anytime you do something questionable, you know, like, this won't work, you know, most cases, but, you know, put a comment there. Like, document the hell out of that. If your code breaks, if somebody changes it, document it. Like, put right there, don't change this line of code. I know it's stupid, but just leave it. Anytime there's something like that, or even if, you know, you just have, like, a variable named rrqtx or whatever, comment, this holds the, I don't even know, rrqtx, the real ratio between irrational and texture. I don't know. Like, just, like, tell me what the acronym means. You don't have to type the whole big variable name every time. That's fine. Just tell me what the acronym stands for, so in my mind I know that this is the ratio between, you know, something and something, right? Like, just explain it. Like, if there's ever a part where somebody looks at your code and goes, huh? Have a comment to explain it. Okay, so let me show you a couple examples of this. Okay, x minus equals minus 1, no comment needed. That is absolutely true, Hazelton. You're absolutely correct. I cringe when I see my old code, yeah. So, yeah, we all do. And unfortunately, my first year of computer science, all of those assignments have been lost, and I'm very sad about that because I'd love to see what my coding was like back in the day. I have, from sophomore year onwards, I have all of my code, but the first year of stuff, I lost it all somehow. I don't even know how. I know I have it somewhere, but I don't know how. All right, so I'm going to pull up the source code for Team Fortress 1. Not Team Fortress 2, not Team Fortress Classic, Team Fortress 1. Okay? And I honestly didn't even think you could use emoji in variable names. You can. Yeah, you can. You absolutely can use emoji in variable names. So here's an example. I didn't write this code here. But it's explaining like what the purpose of these things are doing. So like if a rune can't be reached, then it's going to respawn it. Check if it's been dropped. I didn't write this. Dropped and gone to valid, and so it's checking to see is it invalid. If it's in an invalid location, respawn it. If it's on the ground, if we land on the sky, that's a problem. So respawn it if it landed on the sky. Everything seems fine. Okay, we're cool. And so do you see this, like, do a little magic sound, spawn a little magic sprite. And so it's explaining, it's like a paragraph. For every paragraph of code, there's like a little note. Now, I didn't write this code. This is not my code, but it's good. Okay. So, and so we do this, and then we light it, and then we do a little flash, and this is probably unnecessary. Set next think time. I know, we are setting next think time. I get it. But for the rest of these, this is actually really well documented. Right? So, who wrote this? Check rune spot. Thanks, no problem. Often, yeah, my buddy Often wrote this. All right, good job, dude. So, he lives in Spain, Barcelona. And then here we have the original Team Fortress 1 source code. And this is how the code was handed to me. So basically, they have a list of all the different classes that are available in Team Fortress. And this is not C++. This is actually, everything you see on the screen here is actually valid C++. You wouldn't know it, but this is technically not C++. But everything on the screen is valid C++. So this is the old school C way of making a constant. So this code here, define PC undefined 0, is the exact same thing as saying const PC undefined, almost had that right, PC undefined equals 0. So this line of code here and this line of code here are exactly const int. I'll just leave that off for some reason. Const int PC undefined equals 0. So these are the same thing. Okay, and in C++, this is how you do it in C. So what you're looking at here is more or less C. It's not exactly C, but it's basically C. So, yeah. So here we have a list of all of these different classes that are available in Team Fortress. If you don't know what Team Fortress is, I guess you don't have to worry about it. But Team Fortress came with 10 different classes, plus undefined, which is the class you are when you connect to the server. When you connect to the server, you don't have any class at all. You're an observer, basically. And you can also choose to be a random class. A random class is every time you die, you respawn as a different class. That's kind of fun. Then there's the civilian class. The civilian class is for like special maps and things like that. Like you can have an escort mission where the civilian has no weapons, no armor really to speak of, and they have to be escorted by the team to the goal. And so that person is put on a different class, the civilian class. I added the custom class. The custom class allows you to build your own class. So you can be a spy that has a sniper gun or whatever like that. And it uses a money system, so it's all balanced. And that was my contribution to the world, I guess other than professoring or something. So over 1 million people played this mod, so it's kind of cool. the thing that I wanted to show you though is this here. So they created a variable called last class. And the reason why they have a variable called last class is because they didn't know originally when they're making the mod how many classes they were going to have. When they started off, I think there was only like 6, and they kept adding new ones. And so they wanted to do something like loop over all classes. Like for every class in the world, count how many people there are in that class. And so what they did was they made this variable called last class. And so it is the count of how many classes there are. And so you could say starting at 0, going to less than last class, for that class, count how many people are on that team. And they do that. Like they can limit how many medics are on a team and that kind of stuff. So there is a very important part to all this, which is that if you mess this up, it will break the code. Last class has to be set to 1 higher than the highest class you have in the game. And if you break that, like when I originally wrote custom TF, I was going to add my thing after it, but they documented it. They're like, use this as the high boundary for any loops through the okay, good to know. So if you're going to have something that's going to break everything, if it's not set the right way, you need to put a comment in there so that when people come in and they're like running around, I'm like, oh, okay, I'm just going to add a new class here like this, hashtag defined, you can hopefully they'll read this note, and there's things like this all throughout the code where it's like, if you change this, it will break everything, so don't change it. And so when you go in there, you're like, oh, okay, yeah, I'll leave that one alone. You know what I mean? So, let's see here. Yeah, there's different places in there where they'll have like a like a job. Let's see. Like this one has to be set to be the sum of all of the jobs above it. And so if you ever add a new job or mess with something, you have to change that one too. So it's really important to document anything like that. Or like if one thing changes, caution, if you ever change this is my code, by the way. If you ever change this, it will break everything, so don't change it. Right? So, leave it alone, please. Just don't mess with it. Okay? You guys understand? So comments are really, really important. What you don't want is to somebody, to allow somebody to just come in and like, oh, okay, I'll just change this to, 16 or whatever. If you do that and it's going to break your code, put a big giant comment there on it, and ideally put something in your code too, like if job thief is not equal to 1, die. Like, no, it has to be 1. The server code requires it to be 1 or everything breaks. Okay. All right, so that is Team Fortress 1's source code. Now we're going to look at the source code of Chamois as an example of what not to do. Or let's see, Hazelton's here. Let's look at Hazelton's code. Let's see how well Hazelton did. Hazelton, when did you take CSI 40? Code review time. Hazelton, when did you take CSI 40? CSI 40. Fall of 18, maybe? Yeah, that sounds about right. Let's see, it'd be 10 a.m. maybe. CSI 40. 10 a.m. Costco 40. Fall 19. Okay. All right, so let's take a look at his main.cc. All right, so here we have a function called game over with no comments on it. See out game over, sleep for 2 seconds. Thanks for playing. Sleep for 2 seconds. Made by Brandon Amory and not Lucas. That's hilarious. Sleep for 4 seconds, then it quits. So you could probably get away with not commenting out this one. It's pretty clear what game over should do. You know, combat string boss. So we've got a bunch of variables here. I don't really know what they're doing. General damage, player damage, general HP, player HP. I guess I can understand them. Choice. I guess I get it. If boss is general HP is 12. If boss is boss, general HP is 20. Prints out your noun comment. There's no comments anywhere to be seen in here. Anywhere. Is there a comment? Yeah, what I would do is be like choice 1, attack, right? Just something like that, right? Like attack, you know. What is choice 1? I don't know, you know. Like, and so like when you're reading the code, like it would be really nice if, you know, there's just a little thing here, like a paragraph, like every paragraph of code, toss a little line in there saying what we're doing, okay? It's done at like 5 o'clock in the morning. Yeah. Comments or comments. 3 would be health potion, it looks like. And then also, like, when you're coming through and, like, messing with the code later, like, you can just scroll up and down, like, ah, there's the attack code, there's the shield code, you know. End of comment. Oh, that's the only comment he had. The only comment in the whole thing. Sorry, I'm laughing at you. It's kind of funny. The only comment in the entire function was end of combat function. So, I mean, it's actually fair. Like, people will do that because, like, when you're staring at closed curly braces, it's kind of like, what is this a closed curly brace for? And, yeah, you can always shift 5 and find out, but it's fine. And then he commented out a couple of comments here. Big Daddy pew pew. Big Daddy all dead now. Bye bye. Big Daddy poof. All right, so. Yeah, that's interesting. Okay. Puzzles, so jump out the window, kick the door, invalid input. All right. Again, no comments. Like, what are we doing here? What's the point? What are the variables for? Yeah, this end of puzzle 2. End of puzzle 3. Yeah, probably worth adding some comments in there as well. So. Yeah, there's no comments anywhere in any of this. Except for this one. Yay. All right, here we go. So, we have a sorry. Here we go. The empty comment. Yeah. So here we have a comment. All right. Test user input. If invalid, repeat until valid. Okay. So that's a good comment. Okay. So test user input. If invalid, repeat until valid. So he's explaining what we're doing here. Why is there a while loop with a cn inside of it? And what's going on? This is basically my read code, by the way. Clear, ignore, you know. So it's going to keep reading from the input until the user types in either a 1 or a 2. Okay. So, yeah. Cool. Yeah, probably could use some more comments. All right. Yeah, in general, yeah, you wanna comment your code, and there's this, you know, kind of a gray area as to like how many lines of comments you should have per lines of code, and it's kind of like, again, my general rule of thumb is the WTF rule. Like if somebody looks at your code and goes, "What the hell is that?" It needs a comment, you know, and then beyond that, like if somebody knows what the hell is that variable, put a comment on it. This is the holding the ratio of whatever to whatever. You know, if you want to use an abbreviation, fine. comment it so I know what it is. And then beyond that, every function should have a comment up top just explaining what it does. And if the parameters are weird, what the parameters are. And two, every like paragraph of code in general should have an explanation on it. Okay. So that wasn't from Stack Overflow. The // that's funny. So if you were to look at like my Voronoi, which I misspelled as Voroni, code here, you can see that I've got comments like, this is, my code, right? You can see I've got explanations of like what each of the different member variables are for, explanations of like everything, what the functions do, what 000 means, what does it mean to set color to 000? That means the foreground is black, so it's going to make invisible fonts. That could probably be changed to move cursor to row 0, column 0. Right, it's like a little explanation of like what this thing's doing, right? And that's all you really need, because like an experienced programmer will come in here and be like, move cursor 0, 0. Okay, well, which one's X, which one's Y? Which one's row, which one's column? And so having a little comment like this, like it's moving the cursor and it's row first, then column, that's usually all you need. And then if you want, then once an experienced programmer's seen that, if I ask you to move to row 10, column 20, they'd be like, all right, done, I guess. That's how you move the cursor on the screen, I guess. Okay. So, yeah. So just having little brief notes like that goes a long way. Yeah. So that is comments. And everybody who does it differently from other people are always wrong and should not be hired. Every place has their own culture for how many comments they should have. I'm just telling you mine. I think it works pretty well. It's a pretty good system. Okay. Actually, if you want to look at my header file that I've published, vim public read.h, you can see that each one of my functions has a little header up top. What does it do? It reads a T from Cin, reprompting. Here's some examples how you can use it. And so every one of my functions says this is like getLine, but a little different. It handles errors and stuff like that. It eliminates a common bug switching between double right arrow and getLine, which is something I do need to talk about in this class. Not today, though, apparently. So basically, every function I write will just have a little line. It's just explaining it. And then when you use it inside of if you were to use read.h, watch this. Int x is equal to read. Do you see that? You see that? It actually uses that comment above it. It reads the T from Cin, reprompting if they type something wrong. It shows you, yeah, it goes, And last time, I'm probably at the top of the screen as well. It'll even show the examples and stuff like that too. So yeah, so that documentation will actually appear in your code completion and things like that. So if you shift K over a function, kind of cool how the comment appears in the compiler. Shift K. Oh, cool. Yeah. Wrong, but cool. That's the syscall read, not my read. So, that is the documentation, but it's using the documentation for the system call read instead of mine. Okay, so yeah, all right. So comments are useful. I am using COC, yeah, but it's finding a different read, not mine. All right. Next, math functions. You know most of these already. One thing I didn't talk about before is the rounding function. So there's floor, ceil, and round. If you pass in a number like 5.6, the floor of 5.6 is 5. Floor gives you the integer below the current float. And floor is actually kind of a pointless function because if you just put a float into an int, it floors it anyway. So if you try saving 5.8 into an integer, it just becomes 5. So floor is actually a function I've see kind of no use for, really. I guess if you don't want to make a variable for it, it's fine, I guess. Interesting. Yeah, I probably should change the colors. Bill, can you tell me how to change the colors on it so I don't get this like glowing pink thing every time? Yeah, so ceil, it gives you the integer above it. So the ceiling of 5.1 is 6. It is the integer above the current float. And then round gives you the nearest int. So 5.1 rounded is 5. 5.6 rounded is 6. Okay? Depends on the color scheme. Ah, great. Bright, violet, purple, green, pink, blah. Horrible. Okay, although not green. So, so these numbers are used for rounding. Abs and fabs, you actually don't need to know fabs for the reason we're about to talk about today. You got your trig stuff, your exponential stuff. But yeah, ceil, round, and floor, those are actually kind of useful, except not floor. So, the topic we're going to talk about today is function overloading. And this is something that differentiated C and C++ back in the day. C++ comes from a programming language named C, which is made by Kernighan and Dennis Ritchie, who I think just passed away. Do you use COC on your primary driver? Of course. Yeah. I used to use You Complete Me, but I think COC is better. So Dennis Ritchie, the internet works. Yeah, he died. Oh wow, it was 10 years ago. Just died. My, how the time flies. Yeah. He created the C programming language with Ritchie and Thompson. Yeah, that's right. They made B. He's still alive. This guy's still alive. Yeah, he's a super nerd. I mean that as a compliment. Kernighan and Kernighan. Not Kerrigan, that's StarCraft. Brian Kernighan suggests the name Unix as a pun. Kernighan's name became widely known through the co-authorship of the book on C, but he affirmed he had no part in the design of it. He just wrote the book. Okay, fine. Yeah, so Kernighan and Ritchie's C programming language. This is actually one of the best programming books ever written, I would say. So it's basically a pretty comprehensive guide to learning C. If you guys know C++, you already kind of know C because it's more or less the same language, at least at the level we've done it. This book is really short, it's really readable, and it actually will teach you the entire language like pretty quickly. Bjarne Stroustrup says this is actually one of his ideal books for like technical writing in terms of like clarity and length and all that other stuff. So I have a copy of it around here somewhere. Yeah. So that's it. That's the whole book. Not long. And a lot of it is reference, Unix system interface, pointers and arrays, yeah. So structs, so it's about 168 pages. And that is the entire thing. And you can really compress down the C language to about 20 pages. And in there, it explains the syntax. It's got some paragraphs that are very readable. Then it's got some sample source code showing you how to use them. And it's just a super nice, well done book. And so, anyway. So clarity is something you should always strive for. Anyway, so that's C. C was made back in the day. Then this young fellow by the name of Bjarne Stroustrup came around and said, I could do one better. So, so one of the things that is annoying about C is that you can't have two functions with the same name. We talked about that last time, right? There is the abs function and there is the fabs function. And abs is for ints and fabs is for floating point numbers. And except they're actually not floating point numbers, fabs actually takes doubles. And so when they made a float version of abs, they couldn't call it fabs because fabs was taken. And they didn't want to rename fabs to be dabs because that would break everything. So they came up with fabs F for the float version of fabs. And then you've got labs, LLABS for the long version of abs. And it's a real big pain. It's a really big pain to have to do a different function with a different name and memorize them for every data type. It's kind of annoying. Yeah, it's just kind of annoying. Good coffee. So C++, and this is Bjarne's big invention, one of them, there's a lot of neat things about C++, was that he allowed you to have functions with the same name as long as their parameters were different. Okay? So what you see here in yellow is something called the function signature. So the signature of a function is, well, it's technical, but basically you can have two functions with the same name, and as long as the parameters are different, they're different functions. And C++ can distinguish between them. Note that I did not say the return type. Okay? The return type doesn't play into this. These things in yellow are what C++ uses to distinguish one function from another. So this one and this one are two different functions because this one is add float float, this one is add float int. They're different. If this one was add float float also, it would be the same function. It would be ambiguous and it would not compile. Okay? And then add float float float, that's also different, right? So this one's add float float, this one's add float float float. They're different, it's fine, everything's cool. As long as there is one point of difference between one function and the next, C++ can handle it. Okay? Return type doesn't count. It's got to be in these yellow things here. Either the function name or the parameter list. Okay, so then C++ uses the parameters you pass to the function to pick which one comes out. Okay? So if you have int max taking an int a and int b, brightness on my screen is changing. Mess with this a little bit. Hang on. I've got some sort of like local dimming going on there. There we go. Let's turn that off. So the local dimming is like adjusting the brightness on my screen as COC clicks on and off, like the text is getting brighter and dimmer, and it's really it's not going to show for you guys. Okay, so we've got here a max function, and so we want to call this function cout max of x and y. Okay, so how should I write max? I want you guys to write this for me. Is there any benefit to naming two functions the same? Yeah, the benefit is that you don't need to have abs and fabs and labs and fafs, things like that. It just gets really annoying to document. You know, if it's just all abs, it's great. You can pass a double to it, you can pass an int to it, you can pass a long to it, you can pass a float to it. Abs takes everything in C++. It just makes everything nice. Technically, though, you could do it the C way. Obviously, the C, programming language has been very successful over the years. So give me a max function. It's going to take in two integers, and it will return whichever one is bigger. All right, so COC is also close to one-to-one with VS Code's plugin, so anything that works there works in COC. That's nice, yeah. NVim has their own built-in now. Oh, interesting. Interesting. Does it really? Because I'm using NVim, am I? Maybe not. Huh. Yeah. Yeah, if you can let me know had a set of invms built in. I'd like to try that out too. So I might even enable it for my students. That'd be neat. Anyone else want to give it a shot? Max? In the previous class, the student did this. If A is greater than B, return A. If B is greater than A, return B. Christian server that, but without the else. Yeah, good. So, what's wrong with this code? What's wrong with this code? This is from the previous class. This isn't you guys. What's wrong with this code? What bug can this cause? What case are we not thinking about? You always got to think about the edge cases, right? There's a problem that if they're both equal to each other, we're not saying what should happen, and so we are now firmly within undefined behavior territory. For an int, it's probably not going to cause any serious problems. For a string, it would probably segfault and crash. So let's compile it. And I'm going to compile it without the undefined behavior sanitizer on because I'm just going to default compile it. Warning, control reaches end of non-void function. By the way, you should not consider this to be a warning. You should consider this to be an error. You should never, ever, ever compile your code with this warning. Because you're in undefined behavior territory. Once you're in bat country, and you're tripping on adrenochrome, sorry, Fear and Loathing reference. When you're in undefined behavior territory, it's like Fear and Loathing in Las Vegas. Literally anything can happen. The compiler could have it could delete all the files on your computer. And you're like, wait, why did the compiler delete all the files on my computer? It's undefined. It's anything the compiler wants to do is technically correct according to the C++ standard. If you have written code that has undefined behavior, literally anything the compiler chooses to do is correct. It is not incorrect for it to destroy and overheat your CPU and melt your CPU out through the motherboard. Like the compiler is free to do that, and that would be a conforming C++ program according to the standard. Okay? So, don't ignore this warning. This is actually, to me, it should be an error. But it's there for a reason. And it's there for a reason because sometimes, like in this case, it's covering all the cases, but the compiler can't figure it out, right? So the compiler is not smart enough to know that you have 100% coverage. And so that's why it's just a warning, right? You'll still get a warning. And if you run it, it works fine. But if we take out that equal sign there and compile it and run it, works fine. It works fine. But now let's compile it and run it with the undefined behavior sanitizer on. So this thing here is a bit of code that watches your code as it runs, and if it ever sees your code engage in the bad practice of doing undefined behavior, it kills your program, which is good. It's actually a good thing. So if we compile it and run it, 5 and 4 works fine. 1 and 6 works fine. But if we pass in 5 and 5, death. Right? So runtime error. You did not return a value from a function. You said you're going to return a value from a function. You said you're going to be returning an integer. You did not. And for an integer, it's probably not going to hurt anything. If that's a string, that'll cause a segfault. And so UBSAN, Undefined Behavior Sanitizer, is like a watchdog that watches your program for this kind of nonsense. So there's a couple ways out of this. Probably the easiest way is just doing this. This is, I think, Portnoy and Stover's code. So if A is greater than B, return A. Otherwise, return B. Okay. Now it's safe. There's no, like, if we get past this one here, it'll do that one. Guaranteed. This is our backstop. It'll always return a value. That's technically correct. That's the exact same code, in fact. So you don't need the else, because if the if branch is taken, it returns and it bails out. So it will never get to the second line here if the first line is taken. So the else is kind of redundant. So I would personally write the code this way. I do know some professional programmers that would choose to keep the else in there because they like the symmetry of it or something. It doesn't matter. it won't compile any different. It'll give you the same code. I like having as little text on the screen as possible because it makes it easier to read. Okay, so that's max and that's working. Now, let's change this to be a float. Okay. 3.1, 7.6. Okay. Let's call this mymax because we are actually calling the standard library max right now. That's one of the dangers of using namespace standard, right? Is that if you're not aware of what's in the standard namespace, you can call the wrong one by accident, right? Scout calling mymax. Okay. I was about to say, wait, that was supposed to be an int. Yeah. Please enter a number. Yeah, that's why I was double checking that, right? 6.1. So we get 7, right? So what happened was it was actually calling the overload. We created a new overload for max, and it was not calling ours. It was calling the standard libraries because there was a max already. So I'm just going to call mymax now, and there we go. So it's going to call mymax int. Now, if I make another version of mymax, 1, 2, 3, 4, 5, I'm going to overload it. Boom. Overload for floats. Overload for ints. You'll notice that right now, before I change it, it's not going to compile. You see that? Redefinition of mymax. I've got one with int. I've got another one with int. They're the same. Do you guys see that? Why that won't compile? It's ambiguous. Which one do I call? I don't know. All right. So go back here. Look at the function signature. If I have two of them, both called add float float, add float float, they're the same. Can't do it. It's a redefinition of the function. Okay. You guys see that? Why this won't compile? Even if I change you to be like apple and like banana, it's still the same thing. It's still ambiguous. Because the function name doesn't matter, or the variable name doesn't matter. Right? You see how this isn't in yellow? That's not in yellow. That's not in yellow. The only thing that matters is the signature of the function, the name and the parameter list. Okay. So this will not compile. Even if I change the return type to be float, it still is ambiguous. All that matters is the function name and the parameter types. Okay. So if I change this now to be float, and this to be float, now we got something. All right. So now they're different. So which one do you guys think this is going to call? We're reading in a float x and a float y. Do you think it's going to call integer mymax or floating point version of mymax? Yeah, you guys got it. Run it, calls the floating version. Even if I type in an int, right, and this confused some students in the previous class, but you typed in an integer, doesn't matter. Float, float can hold 0. A float can hold 1, it's fine. And when it outputs it, if there's a trailing 0, it doesn't output it, right? Technically, this value is 8.000000, right? But C++ by default does not print trailing zeros. Okay, so what if we did this? What if we made one a float and the other one an integer? Which one do you think it will call? Will it call the integer max or the floating point max? You just had to guess. Which one would it be? I don't know. Do you see a compiler error there? I'm still in insert mode. That's why there's no compiler error. If I hit escape, then you'll see the compiler error. So no, it's an error. You guys have it. I was being tricky by leaving it in insert mode. This isn't like Visual Studio that will be like error as you're like typing error. Oh wait, no, it's fine. COC will wait for you to hit escape before it does it. So yeah, so we now get this error message here. Call to my max is ambiguous. No, it's still... No, I guess that did change, right? It's ugly. Yeah, why is it always like... It's always like this gargantuan, bright fuchsia color. You PM me how to change it? Alright, thank you. Yeah, it's ambiguous because we've got one int, one float. Okay, so it doesn't work. And it prints out the candidates. You got two candidates here, one for the int version, one for the float version. So whenever you have an ambiguous function call, it'll generate a list of potential candidates that it could call, you know. And what's happening here is that C++ will actually try finding the nearest function. Okay, so if I were to get rid of, like, this guy here, if I were to try getting rid of that guy, it would actually compile. It would work fine. Because it knows how to convert between a float and an int, and it will do so for you. So it's like, okay, I don't have an exact match for int. I got float int coming in here, but it's close enough, and so it'll convert for you. But these two guys are both one conversion away, right? The int version, it would have to convert the float to an int, and for the float version, it would have to convert the int to the float. So they're both exactly the same distance away. They're both one conversion away. And so it doesn't know which one to pick. It's an ambiguous function call. So if we were, however, to change it to be, oh, I don't know, a double, it compiles. Which one do you think this is going to call? It's great. Yes, thank you, Hazelton. I like that. So which one is it going to call? What do you guys think? You going to call the int version or the float version? You get to go into my vimrc file. Thank you, sir. All right. Yes. Beautiful. No more glowing purple. It will be the integer version. And the reason for that is because in order to call the float version, you have to convert two parameters. For the int version, it only has to convert one parameter. So the int version is closer in some sort of conceptual space, right? It's one conversion to go to the int side, it's two conversions to go to the float side. One is smaller than two, so it picks one. And there's a whole bunch of baroque and arcane and complicated rules for what gets called when. And you don't need to memorize them. That is like, you can dig into like C++ trivia, like, all right, what if we put a char here and a char here? What's closer to a char? What do you guys think? A char is a letter, right? Letter A? Do you guys know what number letter A is? I know some of you do because you were here in the previous class. What is char? What is a char? Letter A, 97 is lowercase a. What's capital A? Why was there no compiler error when you call the float when there's only an int? Because it'll convert. You can convert from a float to an integer. That's fine. You just truncate. You just drop the thing after the dot. It's one conversion on the first parameter. It's one conversion on the second parameter. It converts fine. It's only when you have possible candidates to convert to that it explodes. Capital or no capital? Capital A. What's capital A? So if we compile this, it compiles fine. But is it going to call integer or is it going to call float? If you have two chars and you've got your options are int and float, what do you think this is going to pick? Is it going to pick the integer version or is it going to pick the floating point version? What do you guys think? Take a guess. If you said int, you are correct. It will in fact do an integer. So if we type in A and B, it does 66, which is capital B. Okay. So that's C++, and in general, if you're trying to like guess like what function it's going to call here, right? It's calling something. It's not. You know, there's no compiler error. It's got to do one conversion for the char to an int or a char to a float. It's got another one to do a conversion between double to int or double to float. It looks like this should not compile, right? Because they're both they both need a conversion, right? But it does the integer one. And the reasons for that are char is closer to int than, there's like rules on all these things, like how close something is to something else. And you honestly don't need to remember it, because if you're ever writing code like this, where you're passing a char and a double and there's two overloads with ints and floats, you're writing your code wrong. Just don't write code this way. If you're ever in a situation where you have to like consult a C++ trivia expert to figure out which one of your overloads are being called, you're doing it wrong, right? So, you know, you might want to just do this and just make it explicit. We're going to turn you into an int, and we're going to turn you into an int, and we're just going to make it very clear which one's being called, right? If you have to do it that way. There's other ways of doing it, but okay. So, and then in the previous class, I gave them a little bit of a preview for CSci 41. I'm just going to do this really fast and barely explain it, just so you can kind of get a sense of how like real code is written. In real code, we actually don't write 9 million versions of my max with int and int float and float in and float char and double float and double double and double double. We don't do that. Okay, so in real life, we actually write the function one time. This is a CSci 41 concept. It's a next semester concept, but I'll just show you because why not? So type name T is like a fill in the blank. Okay. So rather than specifying we're going to take two integers or two floats or two doubles, instead we say we're going to take in a T. What is T? I don't know. Anything. We can take anything. And so this won't compile because these are two different types, right? So we have a char and a double. So we can do this, however, and you. And now, this function can work with any type and any type. Okay. So it's like Mad Libs. If you've ever seen Mad Libs before, it's like fill in the blank. So it's like these kinds of things where like people will give you a noun and a verb and an adjective and you like fill it in later. It's like that for the type. So like when you have this function here, it's just like, what's the type of T? I don't know. The user's gonna pick, and when we come down here, okay, it's T is gonna be char and U is gonna be double. So it fills in char for this and double for that, and it just works. And it'll work for anything that you can compare. It's like you can't compare like a double and a string. If you try doing that, it's gonna explode. You can't compare a double and a string. That doesn't work. And it's not happy with that. But yeah, pretty much anything that you can compare, it'll work for. So that's CSI 41. You don't have to worry about it. You don't have to memorize it. You don't have to write it down. It's just kind of like, I feel like I'd be amiss if I gave you the impression that people were out there writing 100 versions of every function just to cover all the different combinations of types. You know, what if you compare a signed 16-bit integer to an unsigned 64-bit? No, you just do that. Okay, so that is function overloading, and it's an important thing to get. Let me just compile this real fast. Okay, so let's talk about the homework. There's a couple of really important things for the homework. The first is how srand and rand work. So srand, so first of all, how do random numbers work? So if you were to see out rand, what do you get? You get a random number. You get a random number from 0 to rand max. Rand max can be as small as 32,000, but on our system it's about 2 billion. So if I run it again, should I get a random number? Yeah, there you go. It's a random number. If I run it again, do I get a random number? Yeah, it's random. Guaranteed to be random. You guys notice any similarities in the random numbers I'm getting? They're random. Yeah, they're random. Look, if I do it 5 times, watch. If I do it 5 times, I get 5 random numbers. See? Yeah, it's the same random number, but they're random. See? Every time I run it, I get the same random number. Right? They're 100% guaranteed to be random. So, if you do not, good luck getting true random. Well, we simulate that, right? On a computer system, we simulate it by seeding the random number generator. So if we say srand 42, then that sets the initial state of the random number generator. The random number generator is not random. It is deterministic, which sounds like a paradox, and yeah, maybe. But if I run it with a seed of 42, look, the random numbers I get are different. But every time I run the program, look, I get the same random numbers every time. So they're random numbers. They're deterministically random. And based on the seed that you pass in, you initialize the random number generator to give you that same random number every time you run the program. And this is important for your homework assignment, because your homework assignment is auto-graded. And so that's why the homework assignment asks the user to type in the seed, so my auto-grader can give you, the seed is 42. And then I know what random numbers you're generating behind the scenes. And so I can compare your output and my output and make sure they match. Okay? One mistake that students make is they do this. They reseed the random number generator every time, and that resets it. That resets it every time, and you'll end up getting the same number every time. Because srand, seed the random number generator, sets the internal state of the random number generator to a specific value, and then you'll get the same number back every time. Okay, so the more proper way of doing random numbers is to not use this at all, but this is fairly common. What this does, it seeds the random number generator with the current time, which is in seconds since the beginning of the epoch, the beginning of time, which was January 1st, 1970. And so now if I run it, you'll see I get random numbers. Yay, kind of. If I run it real fast, I get the same random numbers. Because it is in seconds. So if you run the program twice within the same second, you will get the same random numbers again. So it's not actually random. It's just setting it to be, some value based on the number of seconds since January 1st, 1970. Okay, so don't use rand, don't use srand for anything that is mission critical. If you're making an online gambling website, don't use these. If you randomize your blackjack shuffler with the current time, anybody who has any half a brain will also randomize a shuffler on their own machine with the current time and see what the cards are. 19, hit, 2. How did you know 2 is going to come up? Just lucky, I guess. So don't shuffle the way that Magic Online did. Yeah. Yeah. There's actually a standard library function called random shuffle. You can just call that. Yeah, don't try to make your own fancy shuffler that simulates real life shuffling. It's stupid. So is the time dependent off the current time? It is dependent on, here, I'll just echo it to the screen. So it is the number of seconds since the beginning of time. So this counter started in 1970. January 1st, 1970. And it has been very slowly ticking up 1 tick per second ever since then. Okay? And if that looks like a int to you that's in billions, let's see here, thousands, millions, billions, if we are at 1.6 seconds right now, you might be wondering, when are we going to run out of seconds? That's a great question. Because whenever we hit 2.4 billion and change, it's going to roll over. And that is an issue. So that's something called the year 2038 problem, when the counter flips over and hits 0. So, yeah, or a negative number. If you're using a signed integer to hold it, then time goes from being positive 68 years to negative 68 years, and it is now the year 1901. You see that? Overflow. And that's bad, because if you're using this to calculate interest, right, you don't want your year to be wrong when you're calculating interest, you know what I mean? So there it is. It's still ticking up. It's like a time bomb. So wasn't there something similar when we ticked over to the year 2000? Yeah, a lot of people in computer science. It was actually a really big effort, and people kind of joke about, oh, Y2K, nothing serious happened. Yeah, you know why nothing serious happened? It's because there was an army of computer science people going out through old code written in the 1960s and 70s trying to find where the mistakes were made, because a lot of people were holding years as 2 digits. And so when we went from 99 to 00, I got a letter from my bank telling me, thank you for being a customer with us for negative 30 years or negative 70 years. Like, there were actual bugs out there. It was just the mission critical, like, and now it was like, whatever. It was like, you know, this is a letter I got. And I immediately went to check my bank account, because if I had been a customer for negative 70 years, then it's like compound interest running the other way, you know what I'm saying? But it was fine. All the mission critical stuff was fixed. But for cosmetic stuff like that, and yeah, so the Y2K was actually a problem, and people treated it as kind of a joke, but people spent a lot of time and money and effort. You know, you go to the bottom right corner of your screen, you're like, all right, let's set the time to 2040 and see what breaks, you know? So you know, and then you start debugging. So there's probably going to be some jobs in that if it's in 17 years, so you got time. All right, so the one other thing I want to talk about, I know we're basically out of time, but I wanted to show you guys the basic approach towards the hack the mainframe assignment. And one mistake a lot of people are doing is, like, let's say we have secret. String secret, it's equal to pro 9112. And the user's going to enter a guess. A lot of people are doing this. Guess, cn into guess. Right? Bad. This is actually really bad. This is unrecoverably bad. And the reason why it's unrecoverably bad is because cn discards leading zeros. There's no way of getting those back. Okay? Just like how cout drops trailing zeros. Okay? Not an issue here because we're not working with floats. But cn drops any leading zero. So if you were to do this and type in 00123, you get 1, 2, 3. Those zeros are gone. So there's no way of recovering from this. You have to use a string here instead of an int, and then you can do things like check to make sure the number of digits entered. No, don't set it to 0. And 0, 0, 0, 1, 2, 3, or 0, 0, 1, 2, 3. Now you get the leading zeros, and you can check to make sure the number of digits is the same. Okay, so the basic for loop you're going to write for this assignment is the same as for times table. It's a doubly nested for loop. So for every letter in the guess, you're going to go through every letter in the secret and see if there's a match. So I'm not going to do the actual counting for you. The actual counting is going to be something like right equals 0, wrong equals 0, kind of right equals 0. I'm not going to do that. I'm just going to print whether or not it was found. So for size t I equals 0, I is less than guess.size I plus plus. y2i paste, changes to a j, changes to secret, and changes to j. So that needs to be a j also. Copy paste, always gotta watch. So for every letter in the guess, for every letter in the secret, you're also gonna have to make sure they're the same size. I'm not gonna do that for you. For every letter in the guess, we're gonna go through every letter in the secret and see if it matches any of them. So I'm just gonna see if it matches at all. So Boolean matched equals false. Sounds like tender or something all of a sudden. So do we get any matches? No. So we're gonna let's say they type in 1, 2, 3, 4, 5, 6. Okay, the first time through the loop it's gonna be 1. Yeah, char current is equal to guess.at_i. So this is going to be whatever letter we're currently looking at. Like the first time through the loop it'll be 1, next time through the loop it'll be 2, next time through the loop it'll be 3. And then we're going to go through the secret password and see if that character appears anywhere within here. Okay, so if current matches j.at_i. So if so we're going to start at the beginning, go to the end, and if we ever get a match, then matched is equal to true. And once we're done with that, we will say cout secret.at_j. Sorry, I had that completely backwards. So if the secret at j starts at 0, goes to the end. So we're going to loop across the whole secret, and if any of them match, then we are going to output. Let's see here. Just match. Cout cur matched at least one letter in secret. If we did not, we say did not match. So 1, 2, 3, 4, 5, 6. So 1 matched at least one letter in 409, 112. 2 matched at least one letter in 409, 112. 3 is not in there, as it should not be. 4 did get a match. 5 did not get a match. 6 did not get a match. Okay, so this is the core logic that you're going to build your hack the mainframe assignment on. Okay, so rather than just printing out it matched 1 or not, you're going to track how many of them were in the right place, and you're going to find out if they're in the right place by seeing if I and J are the same. If the location of I and J, if the letters there are the same, then it is an exact match. Otherwise, it's kind of a match, and if it's not in there at all, then it's just a wrong guess. And then you're going to just output right, wrong, and kinda, and do it again. So this whole thing here that's highlighted is going to be wrapped inside of another loop that will run 20 times at most. Okay. But that's the core logic. It's just like times table, but looping over strings instead of looping over integers. Okay. All right, that's it, guys. Thank you very much for showing up. I got a meeting to get to. If you have any questions, post onto the Help Center. It is due on Wednesday. Start earlier, not later, so that you can get help when you need it. Don't wait to the last minute. The last minute is too late. See you guys.